Welcome to the tutorial how to set up and operate the IMS SILOX instrument. Please make sure that the following installation requirements are met. We need high purity nitrogen, either a gas bottle with a stainless steel pressure reducer, or optionally you can order the instrument mounted in a 19-inch rack together with the gas nitrogen generator. The following tools are required: a cutter and 3 types of wrenches, as well as a support for the moisture trap. We start with the preparations for the nitrogen supply. Make sure that your bottle is properly secured. Unscrew the cover of the bottle. Take the pressure reducer and inspect if the seal is properly in place. And screw the pressure reducer onto the bottle. Make the connection gas tight by using the appropriate wrench. You also need a cutter and later on the support for the molecular sieve. We get the instrument in its original shipment box. Take the cutter to open the cover of the box. Inside the box you see the cover and an accessories box. We need to remove the protective cover of the instrument. Then we take out the accessories box and the molecular sieve. Place the accessories box on a table to remove the individual accessories. We have a documents folder, the gas tube kit, a LAN cable, the Torx screwdriver set, a power plug and a box with a USB pen drive, an I/O connector, and the power supply for the IMS instrument. Here are the accessories after removing them from their protective bags. We lift the instrument out of the box, place it on a trolley or on the table and have a look at the rear side of the panel. We need to remove the red protective caps. We need to unscrew them. The rear panel shows 3 gas inlet sockets and 2 outlet sockets. The sample in, the calibration in, and the operating gas inlet. The outlets are for the sample out and the gas out. We take the gas tube kit and open it to make the individual tubes available for the connections. Note that we already recapped the calibration inlet. This will not be used in this installation. Now the tubes are ready for being connected. we take the mount for the molecular sieve and open the connections of the molecular sieve with the wrench. The molecular sieve has an inlet and outlet. It needs to be connected to the inlet of the gas, and the inlet should come in a vertical direction from bottom to top. The inlet is now being connected first to the mount, and we take the end of the tubing to connect it to the pressure reducer, the 3 mm male connector. We make sure that the pressure reducer is put to 0, and then we open the gas bottle and set the reducer to have a minimum flow through the molecular sieve. We now connect the outlet and verify that both connections are tight. The moisture trap outlet is connected to operating gas, the inlet, and we verify that the connection is tight, also the connection to the pressure reducer. We now are ready to set the pressure reducer to the right operating pressure conditions. It is recommended to have a value between 3 and 5 bar. For continuous measurements, we recommend a bypass configuration. Remember that the bypass flow has to be at least 200 milliliters. We attach an outlet to the bypass and also outlets to gas out and sample out. These 3 outlets should not have a vacuum sucking on it. They have to be guided into a ventilation hood. And we can connect the sample inlet tube on the other side of the bypass, and this can be connected then to the sample gas source. We take the power supply and use the 3-pin connector to the power inlet. Make sure that you feel a clicking, that the connector is in the right position. Then we connect the power plug to the power supply inlet as well as to the power socket. The system is now ready for being started through the power switch. There is also 2 additional connectors. It is possible to have a connection to the I/O port with the current loop adapter, and there is another option to connect the instrument to a network via an Ethernet LAN cable. Now we power up the system. The characteristic beep is hearable. This is the front panel of the GC IMS SILOX instrument. After switching on, the power LED is turning green and the instrument screen will show various phases of the boot sequence, including showing the gas logo. There is a rotary knob which we can use, or we can use the touch screen once the firmware is fully loaded. It is possible to switch between different tabs. We have seen the result tabs of the start screen, and the scope tab shows the raising temperatures of the instrument during the warm-up phase. It's the so-called startup phase, and we also see a raising reaction ion peak in the middle. For instrument control purpose, it's also possible to use the USB port as an input as well as an output port. We can upload new firmware, we can upload a measurement tag list, or we can export the result report or the measurement files. This is the screen after booting. We can switch from the results view to the scope view, and we see that the temperatures are still raising, and this is causing the blinking here, the error message. The error message will disappear as soon as the temperatures are reached. And we are in the SILOX startup phase. We have a high drift gas flow and we have 15 milliliters carrier gas flow. We already see that the reaction ion peak is quite clean. Maybe after transport or after the fresh installation we can have a bumpy reaction ion peak, and it will need to go through a cleaning phase. Our start screen has the possibility to start the measurements here. It shows us the serial number, the phase and status of the instrument, whether we have a network connection, and the system time. Also, it is possible to see the log of what has happened with the instrument. We have also a substances screen. Here everything is displayed, how the substances are calibrated, and we have a system tab. Switching to the substances tab allows us to see the result representation, the silicium content, for instance. We have here the application mode. SILOX 1 is one application of the SILOX instrument. We have the total silicium calibration range, the total silicium oxide calibration range, total siloxanes range, and the calibration ranges of the individual siloxanes, which also shows the calibration timestamp, and all individual siloxanes can be looked at individually. Once we switch to the Results tab, the Results tab shows us these values and also the measurement tag which has been defined before. In addition, it shows us the status of the measurement, if the system has been working under the requested measurement conditions, the status of the measurement is valid. We now take a closer look at the Systems tab. The Info tab shows us type, serial number, firmware version, the actual date, the IP address, and other IT-related information. The device plan shows us how the GC IMS SILOX instrument is operated. We have the possibility to select a sample in or a calibration input. The gas will be aspired by the sample pump through the sample loop, and we have a 6-port valve, valve 1 here, which switches from filling the loop to the injection position, where we will have the sample transferred onto the GC column, and after separation the analytes will enter the ionization chamber of the ion mobility spectrometer and produce the signals of the analytes. The Settings tab allows us to adapt the IP address either through a dynamic or through a static IP address. We can set time and date. We have the possibilities to reload defaults, and we have the possibility to upgrade the firmware and some other settings of the instrument. We can scroll down. There is a possibility to edit tag lists to allow the user to tag the measurements according to his user-defined tags. Furthermore, there is the information of the GC column or the sample loop and the tube length of the IMS drift tube, the drift voltage, and the fact that we are operating the instrument with nitrogen. It is possible, very important, if there is a problem with the instrument, it is possible to create and export the diagnostics file and send it to gas support. Also possible it is to have a look at the log, the system log. No measurements can be taken, and there is no message at the moment, no error of the system has occurred. We have the transfer settings to communicate with a server to exchange the measurement files, and there are different measurement modes of the instrument. We can select the measurement type, as well as we can send the instrument to a cleaning or to a standby. If we use the standby, we can save the gas. The system is ready to do a measurement. In the system, there is the possibility to edit a tag. There is one demo tag available at the moment, and we can go to the start screen and start a manual measurement. The demo tag offers to add new items. For instance, the concentration, which is currently set on the calibration oven. reaction of D3, and we start the measurement. The measurement progress is shown here. In the first 30 seconds, the system goes to the default flow of 75 milliliters during the measurement, and the EPC carrier gas is set to 5 milliliters. The recording of the measurement starts, and when we are next to the instrument, we will hear the switching of the 6-port valve around 1 minute after starting the measurement. We inject and the measurement can make its progress. It is injected now, and we should soon see some progress on the start screen here in the scope view. The reaction ion peak is as expected, above 5 volts. The first siloxane has appeared. We observe the signal of D3. And we let the measurement make the progress up to the end of the measurement in 15 minutes, and then we will see how the file is being saved and the result is going to be displayed. The L3 signal. The D4 signal appears. And the L4 signal has appeared too. Coming to the end. Normally the measurement is 60 minutes, and here we are ending it. The file is saved and the result report is exported. We can see the result here. We expected D3 to be 1.5 as a lead concentration, and it is 1.4 at the moment. It is possible to have more complex measurement setups, which are explained later, during a 1-point calibration or using an interval. The GC IMS SILOX can also be used to make a 1-point calibration. The idea is here that you need a test gas with a certified concentration, and you can provide a certain distinct concentration. Select the siloxane, which has to be recalibrated, enter the concentration and run this measurement. Once the measurement is successfully completed, it will apply a correction factor to the entire calibration curve. Another possibility is to run the instrument in a continuous monitoring mode, the interval mode. It is possible to select the starting time of the interval, the frequency of the interval, and it is possible that once in a week or at another frequency you can activate a one-point calibration. And last but not least, after a certain time of measurement, you can send the instrument to the cleaning mode.